Assalamu alaikum. Welcome to lecture number 24 of Software Requirements Engineering CSE305 and in today's lecture we are going to discuss requirements validation, and also we are going to start our discussion on requirements management. And this is a process which I really like, and we are going to discuss that where does this process actually comes from, because we started with defining or identifying stakeholders, we collected requirements, we have validated requirements as well. Then why do we need this management? So we are going to discuss that why this is actually considered part of this requirement engineering process, and what is the importance of this particular requirement management process. So but let's conclude our discussion on validation, and before we actually get to that, let's quickly recap what we discussed in our previous lecture. So the topic that we were discussing in our previous lecture was requirements validation process, and we looked at different things which we do during validation. So one of the processes or one set of activities that we perform or we may perform during validation is the requirements review process. And we discussed that what is that review process. We talked about that during that review process, we plan that review, we identify people, during planning we identify people who would be part of that review team. So when we say we identify or when we plan that review, we identify those people. So there is actually importance of that who or what kind of people to be included in that review. So we discussed in detail that what is this what sort of people should be included in that review team, and the people or the stakeholders with multiple set of skills or with broad set of skills, they are ideal or ideal candidates to be included in the review team. The reason is that when we have these kind of people who have knowledge of different processes or who know viewpoints of different other people, then what they can do is that they can sort of identify all the conflicts, they can identify contradictions, because they know all the processes. So that is why these sort of users, they are good candidates to be included in this review team. And then we discussed what is this review checklist. So we said that as when we are performing this validation process, so there is a checklist that can be used to ensure that each requirement is validated and each requirement is according to each requirement is consistent, each requirement is complete, it has no contradiction, and it is unambiguous. Then in our last lecture we discussed some validation techniques which can be used to validate requirements. So number one, we discussed prototyping, and prototyping is a technique that we have discussed already, and we saw that how prototyping can be used during the elicitation process. We said that we can make a small prototype of requirements and we can take it back to the client, and through that process client can actually identify no, this is not what I wanted, and they can actually help you in identifying the right requirements. So prototyping is very useful. Similarly, prototyping can be used here for validating requirements, because now our purpose is not actually to elicit requirements, but our purpose is actually to see whether the requirements that we have elicited, whether they are correct or not. So remember that question that we are trying to answer in validation, that have we got the requirements right? So now what we are doing is that from the final set of requirements, we are preparing a prototype and taking it back to the client and saying, okay, have a look at this and let us know if there are any problems with it. And we say that this sort of prototype, it should be efficient and it should be robust. It is not it is not considered to be a purely throwaway prototype. So it should be efficient and it should be robust, because we are preparing it from final set of requirements. And something very important, so what are the steps which are involved in this prototyping for validation? So one thing which is very important and which is consistent with this review process here in prototyping as well is that we select the people who are going to test this prototype. So we select our prototype testers. Okay, and again, what sort of people should be included, or what sort of the people should be the testers of the prototype? Again, people with multiple skills and people who have knowledge of multiple processes, they are to be included as these prototype testers. And again, the rationale is the same, that why we need these sort of people, because they would have more knowledge, and they would be able to identify, they would be able to use the system in different fashions. Okay, so that is why this is very important. And then next thing that we do is that we prepare test scenarios. So one thing which is important with this prototyping for validation is that we do not just give a running system to the end users and say, okay, just play with it and just go and use it, and if there are any problems then let us know. We actually try to plan the test scenarios, and we tell them, okay, use the system in this fashion, use the system to test whether the critical functionality is actually working or not. So we prepare those test scenarios, and then those test scenarios, they are conducted. And when the users would actually do those scenarios or go through those scenarios, use the system in that fashion, if there are no problems, then it's okay. But if there are problems, then those problems are reported. So problems are identified and they are reported. So that is how this prototyping can be used for validating requirements, that you prepare a prototype from final set of requirements, you identify good candidates for who would be testing that particular prototype, you plan how this prototype is going to be tested, and then those testing is actually done on the prototype, and then problems are reported. Another technique which we discussed, which can be used for validating requirements, was preparation of the user manual. And what sort of things are included? First of all, we need to know that what sort of things are included in a user manual. So normally all the functionality or all the services that a system can provide, they are listed in a user manual. And different sorts of interactions and the behavior of the system based on those interactions from the user, they are also part of user manual. And details of the process, they are also part of the user manual. So when you're preparing that user manual, the person responsible for doing that, he would have to go through the software requirement specification document. He would look at the functional requirements to know what is the functionality or what is the behavior of the system. He would look at the non-functional requirements to know what are the constraints on the behavior and functionality of the product, and through that he would prepare that user manual. And while doing that, that user can identify any incomplete, inconsistent, ambiguous requirement in the document, and then problems can be reported, and so this is another way of validating your final requirements. Then another technique which can be used for validating requirements is model checking. And we have discussed that there can be, during analysis, different sort of models can be used to analyze, to elaborate on requirements, to increase your understanding about information domain, behavior, and functionality of the product. So we can also do model checking. And by checking the models that we have made, we can figure out whether there are some inconsistencies, ambiguities, or contradictions in the requirement. And we looked at one particular example of a data flow diagram for issuing a book or issuing something from the library. And we said that this particular process has multiple steps. So first is check user. When the user is checked, the next is check item or search item, and then is issue item, and then finally is update details. So let's say these are the different steps, or this is our data flow diagram which shows different processes to issue a book from the library. So what are the inputs to this process? So one of the inputs to this process is, for example, let's say we have this process in this fashion, and no input is actually specified. So if we are using an automated tool to check the validity of this model, I would straight away know, okay, there is something missing here. So how would we actually check the user? So okay, then we identify, okay, library card is required, which would be one of the inputs to this check user. But what then? Against which information this would be checked? So again, that is missing. So we are saying, okay, user details would be fetched from the database, which would act as a control information against which his library card details would be mentioned. But again, we say, okay, there is nothing written here, so this model is incomplete, or it is not consistent, it is missing some information. So we say, okay, we need to actually specify that what would be the input to this next process. So we say, okay, user status that whether user is a valid member of the library, whether he is not a member of library anymore, whether his subscription is expired or not. So that status needs to go to the next process. And another input to this process is that which item is being searched. So the detail, for example, if it's a book, the author name, the book title, or its real number, any one of these things, they would be input to this particular process. And then this item would be searched, and then the output of this should be that if this particular item is found in the library, what is the status of that item? So item status would be the output of this process, and that would be input to this process. So again, this model checking is a very useful way of actually ensuring that whether the final requirements that you have produced, whether they are consistent, whether they are complete, whether you have missed on something, whether you have mentioned something which contradicts with another thing in the model. So we say that there are automated tools available for that. But another useful way of checking your validating requirements through model checking is that you paraphrase those models. And this similar model or this data flow diagram, it can be paraphrased very simply. So we can say that what are the inputs to this process? So let's say the first process is check user, or this transformation function, it actually checks the user against the, so what are the inputs to this process? We sort of identify the inputs. We say, okay, the library card and the user status, that is the input. And the control information is the user detail that we have fetched from the database. And we know what is the output of this process. The output of this process is user status. So we can paraphrase these models, and by paraphrasing these models, we can identify if there are any gaps, if there are any contradictions in this model. So model checking is a very useful way of validating your final requirements. Then another technique which is present in industry, which lots of people actually use, is preparing test cases. So when we prepare the test cases, when we write those test scenarios, when we write those test cases, we actually go through those requirements. And that is why it is normally said that preparation of the test cases actually begin as soon as you finalize your software requirement specification document, because it serves two purposes. Number one, you prepare all those test scenarios, you prepare all those test cases. Secondly, it can also be used to validate your requirements, because each requirement that you have written, it should be testable on its own. It should have enough information that it can be tested on its own. So when we are preparing those test cases, if a requirement is not testable on its own, then we have identified a problem. So what we will do, we will have some recommendations, we will give some comments on that. We'll say, okay, this information is missing in this requirement, either restate this requirement or fill that information, unless otherwise this requirement is not testable. So we'll report all those problems. So preparing test cases is a very useful way of validating, or is another very useful way of validating requirements. So this is what we discussed in our previous lecture. And in today's lecture, as I said, we are going to finalize our discussion on requirements validation, and we will start discussing requirements management, which is the final sub-process of the requirements engineering process. So in terms of validation, we have seen that what is the validation process, what is the review process, what are the different techniques which can be used to validate requirements. And towards the end of our previous lecture, we were discussing that how test cases or preparing those test scenarios can be used to validate requirements. But there are few requirements which are hard to test. Okay, so what are these requirements? Number one is the system requirements. So requirements which apply to the system as a whole. So in general, these are the most difficult requirements to validate, irrespective of the method used, as they may be influenced by any of the functional requirements. Okay. So if there is something which applies to the whole system, that would be very difficult to test, because it depends on lots of different functional requirements. So tests which are not executed cannot test for non-functional system wide characteristics such as usability. So for example, it is very difficult to test the usability of the system. You can prepare different metrics, and over the period of time, once you actually deploy the product, you can determine whether your product is usable or not. But just through those test cases, it is very difficult to determine whether the product is usable or not. Then exclusive requirements. What are these requirements? These are the requirements which exclude specific behavior. For example, a requirement may state that the system failures must never corrupt the system database. It is not possible to test such a requirement exhaustively. Okay. Now you cannot actually test this exhaustively, and if you want to ensure your system robustness against this particular scenario, you cannot actually ensure that. You can do it to some extent, but you cannot do it exhaustively. And similarly, some non-functional requirements, they are not testable, and the validation is a very tricky and difficult bit. So such as reliability requirements can only be tested with a large test set. Designing the test set does not help the requirements validation. So if you have a very huge test set, then validation would take too long. So again, there are few constraints with this validation process. Some requirements, for example, which apply to the overall behavior of the system, they are not testable. Similarly, some exclusive requirements, because we cannot test them exhaustively. Similarly, there are some non-functional requirements such as reliability. If we have to actually ensure that my system is reliable, then my test set needs to be large. But again, then my validation process would take too much time. So there are some categories of requirements which are really hard to test. So that is more or less what we have to discuss in terms of requirements validation. But before we actually finish this topic, let's look back at some of the key points that we have discussed and covered in the requirements validation process. So first thing is that the requirement validation should focus on checking the final draft of the requirement document for conflicts, omissions, and deviations from standards. So this is actually important, that validation is performed on the final draft of the requirements. Okay. And this line actually important because it differentiates validation from analysis process, because we know that we do these things during analysis as well, but validation is performed on the final draft of requirements. So input to the validation process are the requirements document, organizational standards, and implicit organizational knowledge. So in terms of that process, we know that what are the inputs to this validation process. So we know that SRS is one input, then we have these organizational standards, and implicit knowledge, which lies with different users, that is also another input to this process. And what are the outputs of this validation process? The outputs are a list of requirement problems. So we have list of all the problems that we have found, and the second output is agreed actions that would be taken against those problems. Then this review, it involves a group of people making a detailed analysis of the requirements. So we looked at the overall review process, and we said that the review process, it's a planned activity. We plan it, we distribute these documents, which is SRS, organizational standards, to all those people, and then they prepare for the review meeting. Okay, so each people or each person who is actually part of that review process, he would be given those documents. He would, on its own, he would actually go through those documents, and he would try to identify all the problems in the document, and he would prepare himself for that meeting. And then when finally that meeting would be conducted, there would be sort of a discussion, okay, between all the people, and they would discuss what are the problems, and they would try to figure out what actions need to be taken to actually fix these problems. And another thing which is very important with this review process, and just by going through that this process again, is that the review costs can be reduced by checking the requirements before the review. For deviation from organizational standards, these may result from more serious requirement problems. So as I said, that there are few things which can be tested and which can be checked for before we go for this formal review. And for that, we can perform a pre-review, okay, where we can ask one of our teammates to walk through the document, and the document can be easily checked against any organizational standards. It can be also checked that whether there are any typing mistakes, where there are any incompleteness in a statement. So we would already know that there is something missing here. So we can straight away point out in that meeting that we do not know what to put here. So let's resolve this first. So it is very important, because these reviews are very costly, and it would take lots of time of different people, and we don't want to we don't want to give a bad impression of our company to maybe the end user, and they are also part of this review meeting, remember. So we want to ensure that when we go for a review, then we have done our best to actually produce this particular document. So for that, we can do a pre-review. So then we said that the checklists, they are a very useful tool to actually ensure that we have not missed on anything during validation. And the purpose of checklist is very similar to what we discussed when we were discussing specification of non-functional requirements. And we said that once we have produced or once we have specified requirements, we use that checklist to ensure whether we have not missed on any particular kind of non-functional requirement. So it's very similar to that. So a validation checklist has been prepared, and so this checklist is a very useful tool. You can keep that with you, and it will guide your review process. So it will ensure that you will not miss anything that you wanted to do during that review process or the requirement review process. Then we discussed multiple techniques which are very useful for validating requirement. We discussed prototype, and we said that how it is very effective, or how it can be very effectively used to test the system. Similarly, we discussed that the system models, they can be used to validate requirements, and these models, they can be paraphrased. So and by doing that, we can sort of identify whether there is any missing information, whether there are any conflicts in the requirements that we have analyzed using those different models. And then finally, we said that test cases can be designed, and by designing those test cases, we can again identify if there are any missing information, if there is any incomplete information in the requirements. So if the requirement is unclear, it may be impossible to define a test for it. And we have said that for each functional requirement, there should at least be a test case. Okay. So if it is not possible to define a test case for one requirement, so it means that this requirement is not complete, or there is some information missing in it. So we need to report it, and so we will identify it as a problem, and we'll say, okay, in order to mention or in order to write the test case for this particular requirement, you need to supply this information because this is not available. And we looked at multiple examples of that as well. So this is our discussion on the validation process. So if we look at these list of sub-processes of the requirement engineering process, and if we try to figure out that in terms of software development lifecycle, that when we start performing these different sub-processes, then we can actually relate to lots of these. So we can say that, okay, so let's try to figure out what we do in these different processes. So we know that we do inception, and the purpose of inception was to identify stakeholders and to identify, why do this client actually wants this product, what are the bigger business goals, and what are the objectives. So we try to answer through a set of questions. We try to determine, we try to gain an insight into why this client want this product, and who is actually the requester of this product, who are the key people who will give me some useful information. And then we go to this elicitation process. And during this elicitation, we said that we discussed that elicitation is a very difficult task, and when we elicit requirements, we go and meet different sorts of people, and we try to gather requirements. And during elicitation, we have discussed multiple techniques which can be used to facilitate this elicitation process. And what we get from elicitation is raw user stories or scenarios. And through that raw information, which is mostly in the form of natural language, which entails that there would be conflicts, there would be problems, ambiguities in it, we perform elaboration. So we try to analyze, we try to gain more understanding into the system. We look at the user stories, we deploy different kind of techniques, and we discussed mainly two approaches: object-oriented approach and the structured approach to analyze or elaborate requirements. And through that, we identify the problems with the requirements. Because we increase our understanding of the requirements, we identify all the problematical requirements, and then we go in this negotiation. And the purpose of negotiation is that we want a consensus. So we want a consensus, we want to get to a final order or rank of requirement. So then we say that we are in a position where we can start specifying requirement. Then come this specification process, and we know that the output of this specification process is this software requirement specification document. And we have done all that, but then we say, okay, no, we need to ensure whether the requirements that we have written, whether they are right or not. So we have another process, which is the validation process, and through this validation process, we again sort of try to identify any problematical requirements, and we take it back to the client. Maybe we need to do more analysis, maybe we need to do negotiation again, and then we have to do specification again, and maybe we need to elicit again. So again, as I said, that this is not a sequential process at all. So it is not happening that, for example, let's say this is the timeline, and let's say my project actually starts here on day 0. So I start my inception here, and then I will start elicitation right with it. But there can be rework here as well. So for example, during elicitation, I might do some inception as well. So that's why these things are happening in parallel here. And then I will also start elaborating it at the same time, and then I would start negotiating as well here, and then I will start specifying requirements here maybe, and then we will validate in the end. But we can have some rework here as well. But then comes this very interesting process, which is the requirement management process. And this is sort of very interesting. And if we look at all those sub-processes, then everything that is sort of relevant to the requirements we have done. We have identified people, we have gathered requirements, we have analyzed requirements, we have negotiated requirements, we have specified them, we have validated them. So what's left to do? Something very important, which is one of the problems with software, in generally software development, is that requirements, they change a lot. Okay, and we sort of see that we have discussed change to some extent during our discussion of these different processes. But the only sort of change request that we have discussed so far results from maybe bad elicitation, or not very effective elicitation, or not very clear understanding of the requirements. So we go back, talk to the client, and then change the requirement again. And similarly, again, when we validate requirements, we identify problems, we go back to the client and then again change the requirement. So these requirements, they change a lot. So change is a very big problem with software requirements. And that is one of the problems that I so often discuss with my software engineering students. And this is one of my favorite questions that I ask to a lot of people, to students in general who are applying for masters in software engineering. And this, I normally ask them that, why do software fails so often, whereas we don't hear that, you know, that a bridge has fallen. So the frequency of the software failures is way more than the frequency of other sort of problems. For example, a bridge may be collapsing or not. So God forbid, you know, it's not a good thing to happen, so it should not happen. But just because I'm a software engineer, so I want to know that what is the problem with softwares. And the reason is that software requirements, they keep on changing. And people actually don't realize that, you know, if you keep on changing, keep on playing with these requirements, then, you know, there would come a time then it would say, no, I cannot take any more. Okay, and then the project is going to fail. So we need a mechanism to ensure, because this course is about software requirements engineering. So we need a mechanism to ensure that what sort of changes to be accepted in the product, how these changes needs to be incorporated, whether a change would be included or not. So we need a specific process which actually look after that how and which sorts of changes I'm going to include in my process. And when I say that we need a process, then this process is not just about accepting, it is actually about understanding the impact of change. And based on that understanding, so when we say change management, then it is not only about, it includes lots of things. It includes, first of all, accepting receiving a change request. Then we need to analyze that change request, and we need to identify, okay, that what is the impact of that change. So how do we actually calculate the impact of a requirement change? That is also part of requirement management, that how we are going to calculate that impact. And then based on that impact, we know what sort of resources we have at our disposal. Based on the understanding of the impact of that change, whether we are going to accept or reject that change request. Okay. Now, if we accept that change request, then we need to adjust our plans.
So that is also part of it. If we reject that change request, then we need to get back to the client and try to give him an explanation that why we think this cannot be done. So it is very important that we have this requirement management process, because one of the main reasons of software project failures is changes in software requirements. So we need a mechanism to ensure that these changes are handled in a suitable fashion. So let's look at what requirement management is about. So as I said, this is the process of managing change to the requirements for a system. And this is something which happens a lot. And believe you me that, believe me when I say this, that when you will go and work in the software industry, then you will actually realize that you start working on something, and your boss would come and say, okay, no, the client actually wants this in a totally different fashion, or client wants this in a, or can we incorporate this into the system? So these things are going to happen a lot. But if this change process is ad hoc and you do not record these change requests, then what would happen is that you won't actually realize, and the scope of the product would increase a lot, which we normally define as scope creep. So because we do not want this problem of scope creep, and we want to know which sort of changes have been already included or merged into the product, we need this change management process. So the principal concerns of the requirement management are managing changes to agreed requirements. We know at the end of the validation process, we have set of agreed requirements, which everybody is sort of happy with. So one of the concern is managing changes to those agreed requirements. Managing the relationship between requirements. Now this is very important. As I said that in order to actually do that, to manage changes, we need to understand the relationship between requirements, because these requirements, they depend on each other. So all the requirements, they are not independent, because we are talking about one system. So if one requirement is changed, then it would have an impact on other requirements as well. So we need to understand that relationship, that how these requirements are linked to each other. Then managing the dependencies between the requirements document and other documents produced in the system engineering process. So if you know this, let's look at any one of those software development lifecycle models. So for example, let's look at waterfall model. So we do analysis and then we do design. So the software requirement document is used, or the requirements, they are used to design the system. Now each requirement would have an impact on one of the design diagram or one of the design artifact that we are producing. So we need to understand that relationship as well. So basically our main concern is to manage changes, and in order to gauge the impact of changes, we need to know the relationship between different requirements. We also need to maintain and know the relationship between different requirements and other artifacts that are produced during the system engineering or during software engineering process. So we know that, so these are the main concerns here. So we know that one important aspect here is the impact analysis of change. And we have shown that these two concerns are actually to do that. So how can we do it? So requirements cannot be managed effectively without requirements traceability. So one of the very important concepts that is used in practice, and that lots of researchers use as well to calculate the impact of these changes, is through traceability. So people perform these traceability analysis, and if we have mapped our requirement to design, to test cases, to different modules of code, then it actually means that we know the trace of our requirement through the system. So for example, we say this was requirement number 1. It affects class diagram number 2, class diagram, and it also affects maybe the state diagram number 1, and it affects, I don't know, module 1 of my code, and a specific class as well. Similarly, I know which test cases were written against it. So let's say I know I have maintained this information, I have maintained this traceability information about my system. And if you guys remember, then initially we discussed traceability very briefly, and we said we are going to talk about it, and now here's the time we are going to talk about it, that there are different sort of traceability tables that can be made. Okay. So a very simple one was, we said that you can maintain information against each requirement, that who actually requested that particular feature and whether you have written any test cases against it or not. So that is a very simple traceability matrix. But you can have more complex sort of traceability matrices as well that you can maintain, where you try to link a requirement to different design artifacts. You link it to all the design documents or all the documents that are produced, and when I say documents or work products, I mean code, design, test cases, everything that is done during the system engineering process. So a requirement is traceable if you can discover who suggested the requirement, why the requirement exists, what requirements are related to it, and how that requirement relates to other information such as system designs, implementation, and user documentation. So this is kind of a comprehensive definition of requirements traceability. So we do not only want to know who requested it, we do not only want to know what's the rationale of this requirement, what is the relationship of this requirement to other requirements, but we also want to know that how this requirements is linked to other things, such as user documentation, such as your code, such as the design documents that you have produced. So this is a comprehensive definition of traceability, and without effective traceability, you cannot know the impact of change, and hence you cannot manage that change properly, and the requirement management is not performed then. So are there any automated tools available for requirement management? So requirement management, generally it involves the collection, storage, and maintenance of large amounts of information. There are a number of case tools available which are specifically designed to support requirements management. Some tools which are sort of the configuration management tools, they can also be adapted and they can be used for requirement engineering purposes as well. So as I was saying, there's lots of support now available. There are lots of case tools for managing these requirements. So what does what should a tool have when we say that it can be used for managing these requirements? So normally it should have a database. So a database system for storing these requirements. You need document analysis and generation facilities to help construct a requirement database and to help create this requirements document. It should have these change management facilities which help ensure that changes are properly assessed and costed for, and traceability facilities. So you need a database where you're storing those information about each requirement. You need so different sort of tools, they can have this feature where you can do this change impact analysis, and we know that we will only be able to perform that change impact analysis if we know the impact of each requirement, and to calculate the impact of each requirement we need that traceability information. So there are different levels to which these tools, so different sort of tools which are out there, they would vary on the type of features or the type of services that they provide to the users in terms of requirements management. So this is a general sort of what would be included in our requirement management system. So you have this requirements document, and you have this requirements converter through which you are storing all the information in this requirement database. And you have this browser through which you are accessing different requirements, and you have this change control system as well, which is sort of part of this, which is sort of one module of the system through which whenever a change request comes in to a certain requirement, you look up that particular requirement, and you try to assess that what would be the impact of change in that particular requirement, and you generate a report then based on that, and you also get these traceability report as well. So there are different sort of facilities that these tools can provide. The one thing that these tools can do is that it's just a database which has stored information about each requirement. Whenever a change request comes in, you try to figure out that what sort of a change request it is, whether it is a change in an existing requirement, whether the client wants a requirement to be changed, whether the client wants a new requirement to be added, or whether the client wants to delete a certain requirement. Okay, so there are three possibilities: either changing an existing requirement, adding a completely new requirement, or deleting an existing requirement. So the next thing that you try to figure out then is that what is the traceability of this particular requirement. You try to know what are the dependencies of this requirement. So as we said earlier as well, that whenever we are mentioning requirements, we try to list down the dependencies of each requirements. So by getting that, we would know that, for example, if we change requirement number 1, then this is going to affect requirement number 2, requirement number 3, and requirement number 6. Okay. And then we try to gauge, okay, how it is going to actually change those requirements. We look at the other traceability information. So maybe different tools can generate the traceability report as well. So it depends, what sort of information that these tools would have. We are going to discuss, making such a tool is a very easy task. You can write your own simulations as well to actually gauge, what would be the impact of a certain requirement on the overall system. We are going to discuss that in later portion of this course as well. But this is just a very generic diagram which actually explains that what sort of the things can be included in our requirements management system. So first we need to understand these two terms, and whenever we talk about changes in requirements, then one term which is coined a lot in literature are volatile requirements. So volatile requirements are those sort of requirements which are prone to changes. There would be some requirements in the system which change a lot. Okay. And the reason is because nobody has a clear understanding of that. And moreover, the client, they do not have a clear understanding of what sort of functionality they want. So they would come back and they would ask you to keep on changing a certain requirement. So normally you need to identify that what are the volatile requirements in the system. So requirement changes occur while the requirements are being elicited, analyzed and validated, and after the system has gone into the service. So there are different level of changes. So as I said that, for example, this is the lifeline of my system, and I started here, and this is where I actually deployed the system. Now changes would keep on coming here as well, and some changes, client would ask for changes even once the system is being used. Okay. As we say that, if a change is identified earlier, then this can be very easily incorporated, but the cost of a change would increase as the time. For example, when the product is actually deployed, then a customer comes and asks for a change request, then it will be very costly. But it does happen. These changes happen a lot. So, and as we say that some requirements are stable, whereas some are volatile. So stable requirements are concerned with the essence of the system and its application domain. They change more slowly than the volatile requirements. So normally it is said that there are some requirements which forms the core of your system. Okay. For example, the application domain knowledge, that is not going to change. So those sort of requirements, they are stable requirements. And because the architecture of your system is actually based on those requirements, so you don't want them to change a lot. But then there are some volatile requirements which are specific to the instantiation of the system in particular environment and for a particular customer. So there would be some features which, for example, let's say we've discussed this example of enterprise resource planning software. Now the core of ERPs, it stays the same. Okay. And as I said that, you according to different client needs, you configure the system. Okay. And each client that you have for that ERP system, each client might have different features that you want in the system. So you might have to change different things. So those are the examples of volatile requirements. So each client would want his different sort of HR functionality. So that is an example of different sort of volatile requirements that can come from it. So what are the factors which cause these requirements to change? So requirements changes. So the change requests, they are driven from two main sources, as I said earlier as well. Requirements change can be, or the requirement change request can come from your own team. So for example, as we saw that through that requirement engineering process, we identify problematical requirements. And whenever we have to fix those problematical requirements, a change request is generated. So requirement errors, those conflicts and inconsistencies, they are one source of requirement change. So then evolving customer and end user knowledge of system. So end user, they also get to know more about their system. When you give them different functionalities, they'll see, okay, so this is what they meant. And then they increase their understanding, and then they would ask for more features. And the technical, schedule or cost problems. At times you figure out that you are running out of money or you're running out of time. So then you try to change your requirements. Then you try to come up with set of requirements which are acceptable as well. And which can be done in the limited amount of time and money that you have at your hands. So there are multiple factors which cause these changes. We know that requirement errors, conflicts and inconsistencies is one of them, evolving customer and end user knowledge of the system is another, and technical schedule or cost problems is another factor which can cause these changes in the requirements. Then you have changing customer priorities. So customer priorities change during system development as a result of changing business environment, the emergence of new competitors, staff changes, etc. They may cause more changes. Then you have these environmental changes because neither the client nor the contractor, they requested those change, but another source comes in and there are some legislation that comes into play. So we discussed the example of e-health systems, and we said that normally the patient record is kept is a very sensitive information, and nobody would want that information to go public. So there are some legislations or regulations which every e-health system should have. So if those requests comes into play, or if those legislation changes, then your system needs to adapt to those changes as well. So there is that type of change request as well. Then you have organizational changes. The organization which intend to use the system may change its structure, and when the structure is changed, then the resulting system should have some new requirements. So these are all the different factors which would cause changes during the software development lifecycle. So then we have different types of these volatile requirements. Some of these requirements, they can be absorbed. So for example, we have a new change request comes into play, and this is a very small change request. And when and the impact of that change won't go into the other related requirements. Whereas we have some sort of volatile requirements which are very costly, and if that particular requirement is changed, then the impact of that change would go to the other related requirements, and it should propagate further. So these are very expensive. So we need to actually differentiate. First of all, we need to identify that what are volatile requirements from this set of requirements, and then we try to differentiate that what are the most problematical of those volatile, or which are more volatile requirements. So for that, let's try to figure out that what are the different types of these volatile requirements. So we know we have mutable requirements. So these are the requirements which change because of changes to the environment in which the system is operating. So if the environment changes, then there's some requirements change as well. Then we have these emergent properties. We say that these are the requirements which cannot be completely defined when the system is specified. So for example, there are some things which we were not clear when we are eliciting requirements. So we got to know more about the system when we started developing it, and few things emerged. And then we have some consequential requirements. So these are the requirements which are based on assumptions about how the system will be used. When the system is put into use, some of these assumptions will be wrong. So some are compatibility requirements. So these are the requirements which depend on other equipment or processes. So there are different types of these volatile requirements. So if we know the type of these volatile requirements, then we can actually sort of manage them in a better fashion. So we know there are mutable requirements, we know there are emergent requirements, we know there are consequential, and some compatibility requirements as well. So it is essential for requirements management that every requirement should have a unique identification, and this is something that we emphasize during specification as well. So because we want to track changes to each requirement, we want to track each requirement through the system, so we need a unique identifier. Okay, we cannot trace a requirement throughout our system through the whole requirement description, so we need a unique identifier, and that is why we said that you should always have a unique identifier in form of requirement 1, R1, R2, or Rec1, whatever you choose, but there should be a unique identification of each requirement that you are including in the product. The most common approach is requirements numbering. So based on the chapter section in the requirement document, you number your requirements. So what are the problems with this? Numbers cannot be unambiguously assigned until the document is complete. Okay. Assigning chapter/section numbers is an implicit classification of the requirement. This can mislead readers of the document into thinking that the most important relationships are with the requirements in the same section. So normally there are few problems with this numbering or requirement identification. So we need to be actually very careful when we are actually doing that. So what are the requirement identification techniques which can be used to actually get rid of those problems? So we have this dynamic numbering, we have database record identification, and we have symbolic identification. So some word processing systems allow for automatic renumbering of the paragraphs and inclusion of cross references. Right. So as you reorganize your document and add new requirements, the system keeps track of the cross-reference and automatically renumbers your requirement depending on its chapter, section and position within the section. So because remember that our goal in requirement management is to know each requirement, and we want to know what is the relationship of this requirement to other requirements. We want to know what is the relationship of this requirement with the other documents that we have produced, we are going to produce in system engineering. So one technique is dynamic numbering. That the tool, for example, if you're using Microsoft Word, then it allows you to reference, it allows you to cross-reference different sections. So if there are any changes in the document, then your document is updated automatically. You don't need to actually manually go and fix it. So that is one technique which can be used for requirements identification. Or if you're using a database, then database record identification is something that can be used. So when a requirement is identified, it is entered in the requirements database, and a database record identifier is assigned. So if you're using a database, then the number is automatically generated by database. So this database identifier is used in all subsequent references to the requirement. So whatever identifier you are using in your database, that is going to be used whenever this particular requirement is referenced again and again. And then you have some symbolic identification. So requirements can be identified by giving them a symbolic name which is associated with the requirement itself. So for example, EFF1, EFF2 may be used for requirements which relate to system efficiency. So for example, all the performance requirements can be then mentioned as per 1, per 2 or so what we are saying is that we give some symbolic meaning to each requirement identifier. So by looking at the identifier, we will know, okay, this is a reliability requirement, this is an efficiency or performance requirement. So we can do that as well. Similarly, and this can be done for functional requirements, not only for non-functional requirements. For example, requirements related to course registration can be also symbolically identified as well. So these are the different techniques which can be used to identify a requirement in the system. So next is storing these requirements. So requirements have to be stored in such a way that they can be accessed easily and related to other system requirements. So possible storage techniques are in one or more word processor files. Requirements are stored in the requirements document in a specially designed requirements database. So there are different ways and there are different pros and cons of using these different techniques. Obviously, there is a cost attached to, if you're using a database, there is a cost associated with it. But if you are preparing to pay that cost, then there are certain benefits that you're going to get. But if you're using a Word file, then maybe it's cheaper, but then there are certain advantages. There are some benefits that you're not going to get out of putting your requirements in a Word document file. So storing requirements in an efficient fashion would mean that how good or how better you can perform this requirement management process. So what are the advantages of using a word processor document? So requirements are all stored in the same place. So that is one advantage that we have, that all the requirements are in one place. So requirements may be accessed by anyone with the right word processor. So you do not need access to database, and you do not need all those things. The requirements are all in one place, and all the people who have access to it, they can actually read it. It is easy to produce the final requirement document. Why it is easy? Because we are not storing each requirements in a database. We are using this Word file to actually, or a word processor file to actually prepare that document. So it's all in one place, and the final document is very easy to produce because you were already using this one document. And what are the disadvantages? As I said, that each technique has its pros and cons. So what are the disadvantages? The requirements dependencies must be externally maintained. So you need an other document, for example, to maintain the requirement dependency. So for example, you need to mention that requirement number 1 is dependent on 2, 3, 4 and 5. Requirement 2 is dependent on 6, 7 and 8. So you need an external, you need to externally maintain this information. Similarly, search facilities are limited. So if you are trying to search the dependency of requirement, then if you are using a word processor, then there's only a certain amount of type or certain type of information that you can actually search for, and it is not possible to link requirements with proposed requirement changes as well. So obviously there are few things that you cannot do when you are using a word processor to store these requirements. and not possible to have version control on individual requirements. So for example, you cannot have requirement 1 version 1, requirement 1 version 2. You will obviously have one requirement. You can have a different version of the whole overall document, but you will not have different versions of one requirement in this document. And no automated navigation from one requirement to another. Obviously, as I said, that some tools, they allow these cross-referencing, so you can say that there is some sort of navigation, but it would be limited to because there is only so much that can be done using a word processor. So there are different advantages and there are certain disadvantages of using a word processor. Similarly, as I said, that if we use a database, then there are also some advantages and there would be some disadvantages of storing requirements in a database. Number one is each requirement is represented as one or more database entities. Data query language or database query language is used to access these requirements. So what are the advantages? We have good query and navigation facilities. So we know that there exist very good database systems. So accessing or fetching information about each requirement, its dependencies, its relationship to other requirements, it would be very easy because our databases, they actually support it very well. So, and its support for change and version management as well. So we can maintain the record about that, what is the number of times this requirement is changed and who requested all the change requests and how this requirement has evolved from its original form to this form. So we can actually maintain all that information. But what are the disadvantages? So readers may not have the software or the skills to access the requirement database. So because using this database, and we know that a requirement analyst or the people who are actually eliciting or storing or telling you these requirements, they may not have all these skills. So using it, and they may not have that software, for example. So that is one of the disadvantages. And the link between the database and the requirement document must be maintained. Even if we are using a database, we have to produce a document. So one of the disadvantages is that we need to prepare or we need to maintain that link as well. So that is it from our lecture today on requirements management, and we are going to continue our discussion on requirement management for, I guess, 2 more lectures. So let's quickly summarize what we have done in our lecture today. We finalized our discussion on requirements validation process, and remember we were discussing that how these requirements, how the requirements can be validated, and one of the techniques for validating requirements was by writing test cases or preparing test scenarios. Through that we said we can validate requirements, but there are some sort of requirements for which those tests cannot be done. So, and we identified that what are those requirements. We said that system requirements is one such kind of requirements which cannot be thoroughly tested, and we said the system requirements are those requirements or those sort of features that are applicable to the overall system, and these things are difficult to test. So through that technique, we cannot sort of validate those requirements. Similarly, there are some exclusive requirements. Okay, and again, those sort of requirements, they cannot be exhaustively tested. And similarly, if we have some reliability requirements, then to ensure that the system is reliable, we need a huge test set. And if the test set becomes very large, then the requirement validation process becomes very difficult. So some requirements, they are not testable. So that technique has this sort of flaw that validating requirements through test cases, at times it's limited because of the type of requirements that we are trying to test. So at that point, we concluded our discussion on requirements validation, and then we started discussing requirements management. And we sort of tried to develop a rationale that why we need requirement management. And it is very important that you guys understand this, that looking at the requirement management process and different sub-processes of requirement management, we started with inception and till validation. We can actually see that we have completed a whole cycle, but we were missing something very key, and that is that requirement changes, software requirement, they change a lot, and that is one of the biggest problems of software project failures, that because these requirements change so often, and you don't even realize, if you do not properly manage those changes in the requirements, you will not actually be able to complete the project within the time and within the cost or within the budget that you specified. So we need a proper mechanism to deal with those changes, and that is what requirement management is about. When we say we are managing requirements, we are actually trying to ensure that all the changes which are requested in the requirements, they are properly managed, they are properly tracked. And there are multiple concerns of requirement management, and the biggest concern is to manage changes. So when we are saying we need to manage changes, there is an aspect to this that how do we actually manage change is we need to first of all calculate the impact of change. And to calculate the impact of change, we need two sorts of information. Number one is relationship between different requirements, and number two is relationship of a requirement to other document. So requirement management, we say the main concern is to manage changes, but we cannot do that if we do not know the relationship of a requirement to other requirements, and if we do not know the relationship of one requirement to the other documents that we are going to produce during the system engineering process. So when we say requirement management, then requirement management is about maintaining that information about requirement so that we can do impact analysis, and by doing that impact analysis we are going to decide whether we are going to incorporate a change or not, and we are going to update all my documents accordingly. So that is it from our discussion in today's lecture, and we are going to continue talking about requirement management. I'm going to tell you that how we can make a very small and simple simulation tool as well, through which we can actually try to gauge the impact of these requirements, or we can try to gauge the impact of changes in the requirement. And we'll talk more about traceability as well. I hope these next two lectures will be very interesting, because I find requirement management really interesting. So till then, take care, and Allah Hafiz.